All right, so we have our graphs, and we have this descriptions up here called domain and range, right? So this is just the low and high of the x values. Okay, so you can see here the lowest value for this particular function sine is what we're doing is right here, right? And the highest possible value is right here. So if you see domain and range with actual values, that means like that's what the first and last number would be on a t-chart. Okay, and more than likely the same thing is true for the range. These are the y values. Now when they're all numbers, it's often that if you plug in the x value, you get the y value here. So you can see that the lowest, smallest value of the domain possible in the domain is the smallest value of the range. And this is a big thing when you get to higher math. Like, what's the possible values that you can plug into the problem? That would be the domain. And what are the possible answers you get? Like when like as we get to do calculator work and stuff like that, you'll get like these errors on the calculator, right? And you're like, what's that? Like, that means you might even say domain error. And I'll say that because, well, that's not a realistic thing you can actually plug into this function, right? That doesn't exist. We can't give you an answer. So that's why domain and range is actually really important, because we don't want to plug in things that, don't really matter or don't really exist. It gets a little more tricky when the domain and range is all, infinity, but we'll talk about that more later on. Now, how this matters today is that the domain and range, when you're doing the inverse of any function, they just kind of switch places. So that's what it says right here to do. Interchange x and y, right? And that will give us the graph of arc sine. So you're just going to go over here and say anything that was not y is now x. Okay. And you'll notice the scales on the graph here have also changed, right? The radians are on the y-axis now, and the Cartesian numbers are on the x-axis. Now, if you recall from geometry, you might already know what's about to happen. If not, I'll refresh your memory in a little bit. But there's obviously a pattern to these graphs. So I'm curious to see if you can spot it. As I mentioned earlier, your domain and your range have now just flip-flopped. So our domain is now the smallest of our x's is -1. The largest is +1. By the way, there's another way of writing this. You might have seen this method a little bit more frequently. These mean the same thing for domain. Just means all your answers or all your numbers are between -1 and 1, including 1. So these are equal to. That's what this means. So these are the same thing, just being expressed differently. Same thing for range. It's from -π/2 to +π/2. Whoops. -π/2 to +π/2. Which is the same as y is all values between and including -π/2 and +π/2. All right, so it's going to look, somewhat the same. 1 comma, all right, 1, or -1 comma -π/2 is right here, right? There's -1, there's -π/2, -1 π/2 is right there. And if you're looking at it like, is that it? Is that all I need to do? Yeah, that's all you need to do. You don't overthink it. There's no trick at the end of this. Now, it's more important that you actually create this on your own, not look at mine and copy it down and say, okay, I got the same graph you do. But create it, know how to make it by yourself, and then check and see, make sure it matches, right? That's way more important, that you know how to create these graphs. There we go. And if I would overlay these, does anybody remember from the geometry days, what do you think they'd look like if I overlapped them? Yeah. So let's look at this on Desmos really quick. Take that off. So we got our sine. All right, we got our sine that looks like that. What would, and the arc sine that you just graphed looks like that. So you'll notice that it's really just a geometrical reflection, right, across the line y equals x. Basically, they're saying, since we interchanged y and x, that's what this line does. It says all the y's are now equal to x, and all the x's are now equal to y. So if you read it forwards and backwards, it kind of, it's very simple, y equals x, but it's actually telling you, this right here is an equation form of this sentence. Interchange the x and y's. All the x's are equal to y, all the y's are equal to x. So when you graph that idea, it turns out, yeah, it just reflects across the line y equals x, right? So you can get really close and notice that if I pick any point on here, that these are equal distance from that line of reflection. And cosine, looks like this. It's from 0 to pi. Remember, that's the domain we want to use for cosine. And then we put on arc cosine. We switch all the x and y's. You'll notice it looks like this. It's like, wait a minute, that looks somewhat different. But if we put that line back on there, it actually, you can see that reflection is happening as well. All right, 3.14 comma -1. -1 comma, this one says pi instead of 3.14, but you can see that the same thing is happening. The x's and y's are just swapping places. We can go that anywhere pi over 2 is 0. Right here it says 0 comma pi over 2. So more of a geometrical review. A little bit of algebra, switching x and y's. Now, I'll give you a little bit of time and let you play around and do the tangent one as well. So I'll give you a chance to figure out, what does arctangent look like? Because it's got some asymptotes and stuff, so it's slightly different, but yet the same process. So as you figured out, the only difference here is that we have vertical asymptotes that turn into horizontal ones, right? So now the undefines are here and here. Of course, the tangent of 0 and the arctangent 0 is still 0, 0. And we always use pi over 4 increments for tangent because those slopes are 1s and -1s. All right, so we got pi over 4, which is a +1, and -1. Oops. Of course, these would keep on going forever and ever that direction. And if we look at it on Desmos once again, see how it compares. Right there. Turn that off. Here's our tangent function. And here's our one and positive 1. There we go. So with all these, we do get that geometrical line of reflection when you're doing this. Okay. So it's just a practice of doing it, and your homework is just to repeat this process one more time, doing that right-hand column. Not a whole lot more, with the review questions of cosecant, secant, and cotangent graphs, okay, from the last lesson, okay? So I'll pass that out right now in a moment. Okay. One more thing. It's all right. Do fill in the domain and range. One little deal right here is that you can see there's some infinity signs. All right, so we haven't dealt with this a lot. Shh. We haven't dealt with this a lot, but there's a lot of infinities floating around in higher math, especially calculus, right? And you'll notice that some of these switched from brackets here, and all of a sudden they're parentheses. That is not a mistake. That is, it'd be wrong, absolutely wrong if I put these here. Okay? And it'd be wrong if I put parentheses up here. So it's one of those small things, like even though it's kind of like a smaller day, not a lot going on, this is one of those big things that can, like, okay, -1, okay, that's more, oh, use a parentheses instead of a bracket. So we'll just notice that now. We'll get into the reason why it is what it is later on. And also get practice doing your infinity signs. Okay. Still got 7 minutes. Okay. Okay. Now the big reason here on why these are parentheses. Okay. Is this. Can you spot the difference between this right here and this one right here? Like, what's the small but very, very, very important difference about these? And that explains why there's sometimes braces and sometimes parentheses. Okay? Yeah. Yeah. They're not equal to. So that's probably the most important thing of the day. If you learned anything today, it's what I just said. So hopefully you were listening to that. Okay? So go ahead and I'll pass out the homework and let you practice on that. We've got a little bit of time. You can check everything out. Okay?